All right, so in this video, we're going to cover complex numbers. Um, First question, what is a complex number? Right, so a complex number has both real and imaginary parts. Okay, if you don't remember, imaginary part has an I with it, meaning it's the imaginary number component. And this is generally how a complex number will look like. Okay, so the real component, so this A part, that's the real part. And then this is the imaginary part. Okay. Now, they get represented in a number plane instead of a number line. So, for instance, if I wanted to say have negative 3 plus 2i, right, that location, right, so here we have our real part and our imaginary. So negative 3 plus 2i would be right here. So that's the location of negative 3 plus 2i. Okay? Now, how do we operate with complex operations? When you're adding and subtracting, all you're doing is combining like terms, right? We treat that I just like it's a variable, right? So when I take a look at this first example, right, we're adding these two complex numbers, right? So I see this addition sign that tells me I'm going to add. So I'm just going to combine like terms, right? Real components with real components, imaginary components with imaginary components. So I'm going to do negative 2 plus 3 plus negative 4i plus negative 6i, right? And that will result in 1 plus negative 10i. And if you want to clean it up, that would be 1 subtract 10i then. So here we're going to end up subtracting. So when you subtract, you want to think about distributing that subtraction sign to the next complex number. So when we're working with it, we got a 4 plus 2i plus 1 minus 5i. Now we can combine the like terms, and we're going to have 4 plus 1, which is 5, and then 2i subtract 5i gets me a negative 3i. So that's going to be our answer here. Next, how do we multiply? Okay. So here we're going to distribute. Sometimes people call it FOIL. When working this one out, it's good to have a piece of paper to work this one out, and you don't want to try to do this one mentally. So I'm going to take this whole expression here, this 4i, and it's going to distribute to the real and the imaginary component in the next complex number. So we're going to get negative 2 times 4 subtract more I plus 6i times 4 subtract I. All right, distribute. So we get negative 8 plus 2i plus 24i minus 6i squared. Right? Combine like terms and simplify where we can. So we can see that this term and this term are going to combine. So I've got my negative 8 plus 26i, and then I squared, right? Remember, simplifies to be negative 1. So that's really subtract 6 times negative 1. So that's negative 8 plus 26i plus 6. And then we can combine the two real components and end up with negative 2 plus 26i. So that's adding and subtracting and multiplying. Next thing you should be aware about would be conjugates. Conjugates are kind of like an opposite for a complex number. How do you identify a complex or a complex number's conjugate? They have the same real components, so equal real components, but opposite imaginary components. All right, so I take a look at these real components here. Oh, they're not even the same. So this one, they're not conjugates in this first example, right? Although the imaginary parts are opposites, not conjugates. All right, taking a look at this next one, -4, +4. Those are not equal either, or they're not the same, so they're not conjugates. Since I'm missing an example of a conjugate here, I'll show you one. You might have something like 5 plus 3i and 5 minus 3i. These two are conjugates. So 5 plus 3i and 5 minus 3i, those would be conjugates. Another thing I might ask you to do is figure out what's the absolute value of a complex number. That has a particular formula. Right, so here's what the formula is. So here's our example. I'm going to define our A's and B's just so it's clear. A is 4, B is -5 in this example. So then, using our formula, we're going to get 4 squared plus -5 squared. You want to make sure you put your negatives in parentheses if you need to. And then we've got 16 plus 25, 41. So our absolute value is the square root of 41. So that's it for complex numbers.